So welcome everybody. Thank you very much for joining us today. My name is Laura Denale from Euronovia. We are the partner in charge of communication and dissemination for the SCORE Horizon 2020 project. So this is the 6th webinar we are organizing within the SCORE webinar series, and it is dedicated to presenting the role of citizen science in monitoring climate change hazards, using in particular low-cost sensors and technologies. The webinar is led by our project partners at University College Dublin. So let me show you the agenda for today. Just a small change in the agenda because since it's snowing in Dublin, the first speaker, Francesco Pilla, will be a bit late. So we will start with Chiara Cocco. But just a few practical information before we start. First is that the webinar is being recorded and it will be made available in the next week in the SCORE YouTube channel. And also due to the tight schedule, we are not taking questions after each presentation. However, we invite you to write down your questions in the Q&A tab or in the chat at any time during the webinar, and we will answer them during the Q&A session at the end. Okay, so I think we're ready to start. I give the floor to Chiara Cocco from UCD.
Okay, morning, everyone. I'm Chiara Cocco. I'm from University College Dublin. I'm assistant professor in digital technologies and environmental design here at the University of Architecture, Planning and Environmental Policy. And today I will actually introduce you what we are doing within the SCORE project in terms of citizen science activities and what are the coastal city living labs of SCORE doing as part of their citizen science activities. There will be a more in detailed presentation by Francesco about citizen science. So I will start immediately talking about SCORE. So one of the key aspects of the SCORE project is actually the engagement of local communities in these coastal city living labs. You will see often this term as an acronym CCLL. So local communities are actually involved, directly involved in the process of observing, interpreting, and co-monitoring local impacts of climate change. And we're doing this through citizen science activities. We are using local sensors and participatory mapping tools. So in this case, you're seeing an image of a not too sunny day in Killiney Beach on the coast of Dunleary here in Dublin, where local schools, students were involved in this Smart Pebble activity and to monitor the dynamics of the beach. And you will hear more about this project. And let me start with saying that coastal monitoring in general is quite difficult and can be expensive, and it often rely on high cost standard instruments with limited spatial and temporal resolution. For example, it's often possible to see data gaps in official instruments. This is a tide gauge that is installed in the Sligo Bay on the west coast of Ireland, and you can clearly see that there are gaps in data collection, and this is actually a problem. And with the SCORE project, we're trying to reduce this vulnerability of this technology and providing a more dense network of sensors. In this case, we call low-cost sensors. So these are sensors which are compared to the high-quality ones have actually a good compromise between quality, data quality, and cost. And we're distributing these sensors to the community, to the local community in our 10 coastal city living labs. with the aim also to monitor. One other key aspect of the SCORE project is the use of ecosystem-based adaptation, which are natural-based solutions that we are testing as a way to reduce the vulnerability to coastal hazards. And local sensors can be very useful in monitoring the effectiveness of these technologies when used, like in this case, in a salt marsh. We installed water quality kits with the idea to monitor the impact of this natural-based solution and understand how effective this is in terms of improving water quality. We started this process of selecting the most appropriate local sensors for our coastal cities, try to respond to key questions for all the cities. What are the local challenges related to climate change and how those challenges are affecting local communities? And last year, we had a series of workshops with our within our living labs, where these questions were asked to the stakeholders invited to this in person, and so usually there were hybrid events where we were asking the stakeholder to help us understand which are the challenges and how these challenges are actually impacting the coastal cities. We also asked them to map existing sensors, existing network of sensors in the city to understand which kind of parameters are currently monitored and which is the spatial distribution of this parameter, and how we can potentially access to these data for the SCORE project. This process has led to the identification of the most important climate change challenges for these coastal cities, and starting with this list of local climate challenges, we have undertaken a literature review. We started looking at the scientific literature review, examining current state-of-the-art in terms of low-cost sensing technologies. And we also combined this with a gray literature review, looking at sources like Axter.io and other ongoing projects which are using similar technologies to co-monitor with the community the impacts of climate change. This process has allowed us to define a list of low-cost sensing technology that could be used within the SCORE project, and we have created an interactive catalog for these local sensors. This catalog is a website, is accessible, and there is composed of two main sections. The first one is this homepage where all the sensors selected through this gray and scientific literature review has been listed. There is a card for each of these sensors, and the sensor, for example, here you can see the smart pebbles I was talking before, and there's the possibility to filter the sensors by hazards, by challenge, climate change challenge, the one we have identified through this first series of workshops with the Coastal City Living Labs. There's the possibility to filter the sensor by parameters monitored, and also by the complexity of the installation process and by cost. As part of this, the second tab is actually a detail page for each of the sensor. In this page, there's quite detailed information about the technology, the historical information in terms of who has tested this technology as part of the SCORE project, a recap of the technical information about the technology itself, information about the complexity of the various stages of the process. So purchasing the technology, assembling or calibrating, deploying the technology with the community, and how the data analysis process work, how complex. And then we have a series of FAQs. This is actually an in-process section where as soon as we get more familiar with this technology, we're adding new information and to make it easier for the person that are actually selecting and thinking of using these specific instruments, be aware of all the possible challenges and when where this is more appropriate to use. When oops. Okay. I wanted to try to actually log in because I want to show you the possibility to, okay, I've logged in. The possibility to select the sensors and create your own shopping cart. So in the case of the SCORE projects, each of the city living labs have a budget to buy low-cost sensors to be used with the community. And there's the possibility to use this sensor catalog to select the technology. And for example, I would like to get 20 of this weather station. So you see, there's really like a shopping cart where I can understand how much this number of sensors will cost to the living lab, and this can be quite useful when working with the when working on selecting the best technology for the living lab. I want to show you also the possibility to, for example, in this case, we are including in the catalog a section for documentation related with the technology, and this will soon also include an onboarding procedure. Currently, this onboarding procedure, which starts with the list of components of the sensor, detailed instruction on how to assembling, troubleshooting techniques to encounter to solve the most common problem with the specific technologies. So this onboarding section will be soon available in the catalog in the form of an interactive step-by-step procedure. In this case, it's currently available as a slideshow, let's say, which starts from, as I said, the overview, which are the main components of the technology, which are the benefits, and then how to assemble the technology. This will also include videos and images directly taken during the prototyping phase of this. So the The Coastal City, the Coastal Cities Living Lab, there are 10 in the SCORE project. They have undertaken a sensor selection, purchase and deployment procedure. 5 of them have already started, have already ordered, and are already starting the citizen science activities within their communities. 5 others are currently selecting the sensors using the catalog, and will soon start the citizen science activities. But let me go through the process these living labs are undertaking. So the first step is actually to get access to the online catalog of local sensors. In this case, we organize one-to-one meetings with the core team of the living lab and the key stakeholders to introduce the catalog, present the technologies, and respond to any questions the living lab may have. The second step is to shortlist those with the stakeholders. So usually this is an internal meeting coordinated by the living lab core team, where together with the stakeholders, the sensors are selected using the shopping carts, and also possible locations are identified as part of this process. Then the procedure continues with the purchase of the sensor. It's also highly recommended to identify local supplier to purchase the sensor. This will definitely facilitate the procedure. And there is a second, usually there is a second meeting with the stakeholder where once the final set of sensor is identified and purchased, then the actual location for these sensors is identified, and is also identified which are the local community groups to be involved as part of the process, of the deployment process. And then the citizen science activities are carried out. In this case, for example, you will have the possibility to hear more about the Dublin Coastal Living Lab experience. Ronan from the Dublin County Council will speak in a while. But the process in Dublin started with a public meeting where the catalog was introduced, and we start identifying the possible number of sensors and the locations. So each attendees, each stakeholder had the possibility to provide his own idea and discuss and negotiate with the other stakeholders, because of course the budget is limited. And the interesting thing is that we also ask about possible technical and public stakeholder to be involved in the process. The same process has been, or a similar process has been carried out by the other Coastal City Living Labs in Villanova in Spain. They have started last year in May with a meeting with the stakeholders, and before the end of the summer, the final list of the sensors were selected and ordered by local suppliers. Then once this was once the order was placed, then they started thinking of the exact activity to be carried out, in this case with the master and high school students in a local beach. So in this case, they were purchasing water quality kits to be deployed in this beach. Similarly, Oeiras in Portugal, they had a workshop with stakeholder where we facilitated the process remotely, developing for them a mapping tool to identify the locations of existing. And you can see here they were mapping the existing sensor network and the new proposed one. And of course, they had a meeting with all the technical stakeholders to agree on the list of sensors and locations, and request authorization and provide prior notice to other local bodies to start the citizen science activities. And of course, this is not an easy process. We are currently trying to assess which were the most which were the challenges and the lesson learned, to be ready to provide more support to the other 5 coastal city living lab, which are currently starting this process of selecting and planning their activity with the stakeholders. I think my time is also finished, so I will stop sharing and leave the floor to Jose, which will go more in depth into the mapping tool we have developed and some technical aspects of the process.
Okay, thanks, Chiara. Hello, everybody. I'm Jose Pablo Gomez. I'm a postdoctoral fellow in UCD in the Spatial Dynamics Lab, working on a score. I will share my presentation. I will cover two topics mainly. Give me a minute. Do you see the presentation, right?
Yes.
Okay, so mainly I want to continue with the process of the management of the sensors, focusing on the onboarding on the last part. After the selection of the sensors using the catalog, we go into the onboarding and then into starts having some data to visualize them. And the final thing is another way that communities can engage of getting data in the field using geoforms and geosurveys and participatory mapping activities instead of sensors itself. So related to the sensor onboarding, the complexity of the SCORE projects is very interesting because we have a diversity of living labs. We have a diversity of challenge, and that means a diversity of sensors, and that means a diversity of technologies. So we are trying to put this different challenge into one platform that can manage these different technologies, these different sensors, these different hardwares into one platform. So that means that the onboarding of them can sometimes needs to be per case, sensor by sensor. But from the beginning of the project was defining to use a standard. So that technical standard is saving us, the project, to have in a sole platform this diversity of sensors. This is a OGC, Open Geospatial Consortium standard that is called Sensor Things API. And based on that standard that the University of Pisa and the Antero is managing, we can integrate all the different sensors from the citizens. So I'm going very quickly with the process. The citizens in the CCLLs are they pick the name of a sensor, then they locate the sensor on a map. Then we have the connection with the catalog. This one is very interesting and very important, the catalog that was presented by Chiara, because based on that selection, we have the different properties of the different kits that have different ways of connecting into the IT. So after selecting the kit, the user follows an installation guides that depends on the technology again. And after following the installation guides, the user enters a sensor ID. So all of this is saved into database, connected to the catalog, connected to the API, Sensor Things API. And then based on that, the system, the onboarding is going to generate now the data stream for each property that the specific sensor measures. So the process involved are the registration of the sensor in their own platform in some cases, then the registrations on the SCOR's Sensor Fix API. Another process involved is when there is no connectivity or the data needs to be uploaded manually. Also, SCOR is developing some data collectors. Sorry, that means the data will upload their web app to upload the data directly. And in some cases that a connection can be directly following the infrastructure of the proprietary sensor. We have the so-called data collectors or data harvesters. So when that happens when the Sensor Sync API, the SIP, the platform of SCOR, pulls the data from other systems. That will be the case of areas, for example. So after the sensor selection, the sensor type in this part is very important, because based on the Sensor Things API technology, we can have the sensor type, then we can have the observer property, and we can have the unit of measurement. What is the thing that the sensor is observing? Can be the temperature, and the unit of measurement can be the different Celsius or Fahrenheit degrees. So this is very important. This information comes from the catalog, is connected, but from the catalog that Chiara presents, we need to standardize this information that is behind the selection of the kit from the final user in onboarding, to have put into place all this information to create the data stream. And then finally, from the data stream, we can start pulling or posting the observations. The final step that we are working on this sensor management for the CCLLs is the sensors map for them. At the end, having the observations, we can access them from the SCOR Sensor Things endpoints, and we are preparing the sensor map that I was saying. The sensors is under development now. The map is also is going to have the last observation. The observations are going to be refreshed mainly every 15 minutes, in some cases 5 minutes, the last observations. And also we will have in some kind of time series on each of the different sensors, and this data will be also available to be downloaded from the CCLL, so for anyone that access and also makes any kind of an analysis, plus if it's needed, plus the time series that the platform will be showing. Okay, finally, the other data collection activities that we are offering to the CCLLs and we have in the SCOR project is the community Geosurveys. These ones is a nice platform, because any citizens linked to a living lab can create their own map, can create their own place or location types that they want to map, and also their own questions that need, and maybe that the community in the field, in the city or in the coast have interest of mapping. So we can go very quickly to a demo of how to create your map. I don't know if we have time. I want to ask Laura, because that one will be the nice thing. We can create a small map in this moment if we have time.
How long does it take?
5 minutes maybe.
Yeah, because we are already a bit late, so
okay.
Yeah, very quickly.
Very quickly. Okay. So the user starts with kind of sorry, I'm going to copy paste the thing that I prepared with the name of the map. Then selects the city coastal living lab. In this case, I am making an example for Sligo. When the data are going to start the contributions, then when the campaign for mapping will end. Then this is a section about the map. In this case, let's put something like this very quickly. And after that, if all goes well and the service responds quickly, that now is in the testing one, we will start having the different map position and the different questions. So we are here. We want to go maybe into this part of the map from Sligo. Then the categories in this case is about ABIs in Sligo, so we can start with some. Then, for example, another one. This one is the colors of the icons and so on. And finally, let's have beach nourishment. So after that, the CCLL can start with the questions. And for example, let's only do one questions. The different types of questions are the text area, drop down selections, the check boxes. In this case, let's pick a text area and finish with the map. As you can see, the CCLL can place into there any type of questions. Multiple selection when the user selects the selection from the drop down or for the other check box, the user can enter any of the options that are going to be available for the people to select. So here we have the map center, we have the information about the map and the different types of locations. In this case, we add 3, and then the user can start mapping with different. Actually, here we have better to have, for example, this kind of imaginary, and the user selects the location and then starts with the different responding the different how do you say questions that was prepared for that, adds an image and then submits the data. So this is for example the area. No, we are in Sligo. The area where the different citizens can search for their own maps. For example, the city of Sligo is going to go and there is a map about the ABS in Sligo. I want to contribute, and then the CCLLs can do some community engagement activities by mapping their local areas. For me, that's it. Thanks a lot.
Thank you. So we give the floor to Ronan to present the case study from the Coastal City Living Lab of Dublin. We cannot hear you. It's the connection is bad, I think. Maybe you can turn your camera off if it works better. No, your voice is it's not we cannot hear you.
Okay.
Now, yes.
Can you hear me now?
Yeah.
Great. Okay. I'll try with the camera again because my connection should be good.
Okay.
And I will share. Okay. So can you see my screen?
Yes. Perfect.
Great. Okay, well, let me introduce myself for starters. I'm Ronan Hearn. I work for Dún Laoghaire-Rathdown County Council. Dún Laoghaire-Rathdown County Council are a partner with the other bodies in the SCORE project. Specifically within Dún Laoghaire-Rathdown, I lead on digital strategy for the organisation. So digital strategy is about emerging technology. It's about engaging with citizens and engaging with academia, because the challenges that are faced by local authorities nowadays are they're the kind of challenges that we need to team up with the wider community, especially the academic community, to figure out what we're going to do about it. So SCORE is a really good example of that, because what SCORE does is it makes real for our citizens the challenges of climate change. But unlike some approaches to climate change, what SCORE also does is it makes very real what we as citizens can do about it, and how we can help people to understand climate and to get good data on it, and ultimately to start doing things like eco-based systems interventions that will help mitigate the effects of climate change. So let me just run through the slides. So as I've said, Dún Laoghaire is a partner on SCORE, and sorry, I'm trying to get this to present for me properly. Yeah, and what that means is that we've had a look across everything to do with climate change, and we've worked with UCD, and we've done the citizen engagement and involved the community to try and figure out what kind of sensors we can deploy in the environment around us to help us better understand the changes that are happening and figure out what we can do about it. So I'm going to run through some of the interventions that we have done here in Dún Laoghaire Coastal City Living Lab. Bit of a mouthful. So I suppose the first thing that we needed to do was to bring the community together, to engage with the wider community through our public participation network, through our community, and to start mapping with the community the interventions that might be needed. So attendees were asked to identify the locations, to identify problems in the local area, and to start thinking about how you would go about actually sourcing sensors, deploying sensors, and gathering the data. Killiney Beach was identified pretty early on in the project as a location that suffers from coastal erosion, and this poses a particular challenge for Dún Laoghaire and for Irish Rail, in that there's a chance that it will encroach on the rail lines. I'm just going to play this video, which gives a really good overview of the engagement side through Dún Laoghaire. Let me know if you can see it and hear it.
So Dún Laoghaire County Council have just launched the Climate Action Plan for 2024 to 2029. As part of one of our actions in the plan is to support the EU SCORE project, to understand what's happening along our coast, how we can protect the infrastructure, public transport, such as the Dart line that runs along the coast. So this project is really important for understanding what's happening on our beaches and what we can do to protect them. The incidence of more extreme weather events is increasing all the time. So we need to understand how that's going to impact the coast and the services that we provide.
I just generally think really interesting that we get to discover more about our beaches. I think it's really good that the community is getting involved, so the children around the area can learn about it.
We've been delighted to be part of the Smart Pebbles project. It's been a great collaborative project between a few different schools. My class has really, really enjoyed being out in nature and exploring the sea, the coastline, and they've really developed a big interest in their local area because of the project.
We take a personal interest in this beach because we're always very concerned about erosion, about what's happening to the sand and the sea. And many of us are daily swimmers also. So this project of having these magical pebbles on the beach where we can trace erosion and movement over time is really very, very important.
Sorry, now excuse me, but So the pebbles that you saw there, that's kind of a mix of high tech and low tech there, because essentially what was going on with those pebbles was there was a little sensor put into the pebble. The pebbles were drilled, and the school children went out in the first place and gathered all the pebbles from the beach, like 200, I think it was. Then they were drilled with sensors put in, and then the pebbles were scattered across the beach. The idea being that you come back in 3 months and 6 months and you see where the pebbles have moved. So you get an idea of what's actually happening in a very real sense with coastal erosion. In Booterstown Marsh, some of you may be familiar with it. A marsh was created at Booterstown when the Irish rail line going along the coast was built. And it's a unique kind of a habitat insofar as it has fresh water running into it, and it also has seawater coming in with the tide. So it's important that we measure what's going on there with the water quality. So that was another example of a really good citizen engagement piece. You can see the community members that were involved with us down at Booterstown in deploying the sensors and gathering the data from it. With Dún Laoghaire Further Education Institute, we installed a weather station on the roof, and this will feed back into ourselves and into the Met office and provide more information on local weather. In Carysford, there's sensors being put into the pond there, again to measure the water quality, and this helps us to understand what's going on, not just locally there, but also in Dublin Bay as the pond ultimately flows into there. So I've mentioned the weather station air quality network being rolled out across the county as well. And that's pretty much it from me. What do we see? I suppose I should round up by saying it's been a really, really interesting project. It's been great to work with UCD and with the local community. And I think projects like this make it really real for students and for community groups in understanding not just the challenges of climate change, but what we can actually do about it as well. So thank you for your time. I'll stop sharing my screen now.
Okay, perfect. Okay, so good morning, everyone. My name is Francesco. I'm a professor in UCD. So, I will give you a short talk about citizen science and what it is and how it can be beneficial to do something about climate change. Well, in the original planning, that should have gone first, but my apologies, got stuck in snow. So in the snow here, so it will go last. Hopefully, still makes sense. Citizens, is it changing the slide?
No.
Oh, okay. God.
Yes, now.
Okay, I think I'll have to go this way. It seems to be temperamental with this. So citizen science is a term that is used to define an activity where basically a scientific activity where citizens have a meaningful contribution. So it's generally an activity that is run by an academic like myself, who needs to collect data at a larger scale, and so it kind of engages citizens to help him with the collection of data and also contributing to other scientific related activities. Well, you see, if we look at, and I guess is not changing again. Well, I'll go like this. If we look at different kind of collaborative models and engagement models, citizen. So we go from what is traditionally about basically informing people. So traditional presentation where there is an academic standing in front of an audience with slides, There are other models which are about consultation, which are generally questionnaires to obtain information. Models that are about involving citizens, which are generally workshops. Well, citizen science will actually sit in these last two categories, where basically the scientists engage the citizens in a meaningful way in his scientific activities. Basically, he or she collaborates with the citizen to carry out a research project. And finally, it sits also in a more engaged fashion, where actually this group of the citizen science activities is actually to empower a citizen to carry out the activities themselves. So it's in this model, the scientist is actually out of the picture. It is the scientist's role is about about facilitating the activities, but the citizens take full ownership of identifying the issue and also carrying out the activities to monitor and solve the issue. So as I said, citizen science, it is an engaged form of activity, so it sits in between these collaborative and empowering models. Well, just to give you some examples about what are these collaborative empowering models that are used for citizen science, you see, it is as an example of some examples of citizen science activities which use this collaborative model are the one that I'm showing in the picture. They are generally called passive sensing, which is basically about it's not a really active role. Basically, the citizens share a resource that they have. That could be like the garden or the facilities, and they install a sensor for that is going to monitor basically the data for the scientific activity. An example of this is the Operandum project that we did here in UCD some years ago, but it's also just to make maybe use a more concrete example that people might be more familiar with, the weather underground application. So your citizens are asked to install a weather station. They collect the data and they share the data with the scientific community, but also with the open general public community. So that falls under the category of citizen science passive sensing. There's another collaborative model which is called volunteer computing. This is still about sharing a resource. The citizens share a resource with the scientist, but in this case, it's about sharing unused computational power. So they basically asked to install a little software, and whenever they don't use their computer, their computer is part of a bigger machine. So it becomes all of a sudden thousands of computers become like basically a distributed supercomputer. This approach is used by IBM, and it's been used very successfully in climate prediction. So to do simulations that will take they will require a very powerful supercomputer. So in terms of simulating flood risk and stuff like that, or climate variables, changes in climate variables. So it's been used successfully for this kind of approaches. Then other collaborative models are more traditional one, like the one that is about environmental and ecological observation, which is about basically monitoring some environmental variables or counting birds and stuff like that. And then we move to some more involved models of citizen science, which is all about where basically the citizens define the issue that they want to target. They take ownership also of the monitoring, and in some instances, they actually build their own sensors and analyze the data themselves. Or in this model, as you can see from the little picture with the dots, the scientist is actually out of the picture. It is there as a facilitator. It provides tools, skills to the citizens, and then the citizens are off on their own to do their own assessment. This approach falls under what is called participatory sensing or civic and community science. It's been used very successfully in several projects. As an example, I have there the Everywhere project, is an Horizon 2020, where basically the citizens monitor, they had issue with noise around the Heathrow airport. So they engage with scientists, they monitor noise, and then they push the airport authority to do something about it. So to change the trajectories of the flights to reduce the noise, and so on and so forth. It was also used in one of my projects in Week Count, which was about traffic monitoring with similar approach, and it's what we are also aiming for in SCORE. So basically giving a local community an active role in tackling local challenges, as Ronan was saying, and engaging them in solving the problem, in doing something about climate change. So, well, just to close up, just to explain a bit further the difference between the two models. Well, here actually, let's do it like that because the animation don't work in this game. So here is where we have the scientist in these two models. So just to illustrate the difference between the two models. Here we have the scientist. Here, the scientist in the empowering model is just a facilitator. So basically, just to explain better the difference between the two models, in the one that we have, the collaborative model, basically the scientist is at the center. He basically coordinates the activities. He tells citizens what to do, when to monitor. He analyzes the data. So instead, in the empowering model, the scientist, as I said before, is just a facilitator. He provides the citizens with skills, knowledge, and potentially tools to analyze the data themselves. And then that's pretty much what it does. It basically oversees the activity. So the fundamental difference between these two models is that if we use a collaborative model for citizen science, once the project ends, more than likely the citizen science activities end with the project because the scientist is out of the picture, there's no coordinator, so they tend to die out. Instead, if we use an empowering model, there are more chances that the citizens acquire the skills, acquire the tools, and they are able to maintain the legacy of the project even when the project is over. This is why in SCORE we are going for this model. This is why we are providing educational tools for citizens. We are training them how to use the sensors, how to use the platform. We provide them with simple tools to analyze the data, in the hope that whenever SCORE is finished in a couple of years, these activities will be maintained, and the activities to tackle climate change will be maintained on the long term. And with this, I'll end. I hope I was not too long. And thank you so much again for having me here.
Thank you for joining. Thank you very much. Okay, so I cannot see questions. I don't know, Chiara, if you want to say something as a conclusion. Otherwise, I also wanted to encourage the people attending today, if you have questions coming to your mind in the next days or weeks, you can always contact us because we have a website, we have a contact page where you can reach us. We are very active on social media, so you can join our LinkedIn, Twitter accounts. And we are very available to answer any questions you may have. Just to show you the website with the contact page here, and we have an email address and links to our social media. So thank you. So, Chiara, I don't know if you want to conclude or if it's...
Yes, no, just to say that also the presentation, I think, will be available for you. So the catalog, the Geosurvey platform, you can explore them and get in contact if you have any questions. But I think today we have tried to provide you an overview of the SCORE project citizen science activities, why these are important, and also from different perspectives, you know, from the technical parts, from the university, which is supporting in the prototyping, and also from the local authority, which we really hope will, as Francesco said, will continue to promote this kind of activity even after the SCORE project.
Okay, perfect. So the recording of this webinar will be made available next week, and so on our YouTube channel, and also we will send all the participants an evaluation form for the webinar. Thank you very much to all the speakers and the participants as well, and see you soon next webinar.
Thanks.
Hopefully. Have a nice
Thank you.
day.
Okay.
Bye.
Bye.